Hi, welcome to myprocesspaper.com. Now let me discuss about the title of the process. Our title is Experimental Comparison of Classifiers for Breast Cancer Diagnosis. The main objective of the process is to give the better accuracy results and also to produce better classification results. It provides better efficiency when compared with the existing system. This is a process for evaluating the classifiers for when applying or when diagnosing the breast cancer. Its main objective is to evaluate the better performance results among three classifiers by using the various types of data sets. Now let me discuss about the abstract of our process. The aim of the research is to find out the best classifier with respect to accuracy in detecting the breast cancer. In the performance criteria of the supervised learning classifiers such as decision trees and SVM are compared to find the best classifiers in the cancer datasets, WBC datasets. In the performance of support vector machines, that is called SVM, and decision tree are compared to find the best classifier in WBC. Support vector machines, also called as support vector networks, are supervised learning models with associated learning algorithms that analyze the data and recognize the patterns and used for classification and regression analysis. SVM proves to be the most accurate classifier with accuracy of 96.99%. The aim of this research is to find out the best classifier with respect to accuracy in detecting breast cancer. In this we are breast cancer diagnosis model. So it consists of two phases, namely training and testing phases. The training and testing phases includes the 4 steps, where acquisition step and then pre-process, feature extraction, feature selection, whereas the testing phase includes the same 4 steps in the training phase in addition to the classification step. So in acquisition step, the sensor data are subject to the feature extraction and selection process for determining the input vector for the subsequent classifier. This makes a decision regarding the class associated with this pattern vector. It achieves more accuracy when compared with the existing system classifiers. In the k nearest neighbor classifier classifies the instances based on their similarity, so it takes too much time consumption, but in the proposed system it consumes less time for computing the similarities. Now let me discuss about the data flow diagram of our process. In our process we have 2 phases, testing phase and training phase. So in the testing phase and training phase, 4 steps are equal, but in the testing phase classification is added. Classification step is added. So the first process is data set collection. After that we have to pre-process the data set. After that we have to extract the features in the data set. After the feature extraction process we have to select the features for multiple data sets used in the process. So after that it will be forward to the testing phase. In the testing phase classification process will be added. So in that we classify the data by using the Benningen and malignant parameters. By using the parameters or class labels, we are going to classify the data set. So in this for classification we are using 2 algorithms called SVM and decision tree. So in the SVM classifier we generate the rules for classifying the data. By using the type of rules or patterns we generate the or classify the data in the data set, and then after that we classify the data set based on the SVM. We apply the decision tree for classifying the data. So in the decision tree we are calculating the information gain, information entropy, then gain values. Based upon that values we are going to classify the values. After that we estimate the results, classify results for decision tree. We compare both the SVM classifier and the decision tree. This is a data flow diagram for our purpose. Now let me discuss about the demo of our process. First we have to run home.java. So our title is Experimental Comparison of Classifiers for Breast Cancer Diagnosis. Here we are using 2 types of classifiers, that is called SVM and decision tree. For SVM we have to run the process. Go to the home page .java, right click the page and and choose your data set. Here we are using cancer data set. So in the data set we have some attributes like ID, clump thickness, like that. Then convert that file into the AR format. In that we have the relation name, then attribute name, and data below the attributes. The attributes are in that processes present here. Then create table in the database, then extract data, then load the data into the database. From the database, here we can view the data, classify the data based on the subtable values, class table values. Here we view the data, then click extract button. Based on the malignant values, here we view the data set, and then based on the benign value, here we show the values. So the attributes in the data are ID, clump thickness, cell size, cell shape, marginal adhesion, epithelial cell size, bare nucleoli, band, chromatin, nucleoli, mitosis, and class labels. Then click next button. This is a SVM rule generation frame. In that we are going to generate the rules. For example, in this we are going to take the attributes as a clump thickness, bare nucleoli, chromatin level. So based and then nucleoli level. So based upon this four attributes, we are going to predict the cancer or affected data in the data set. So in this we are generating the 17 rules. So if of A1 does not equal to M1 means M1 is a some value threshold value, M1, M2, M3, M4 is a some threshold value. So based upon these rules we are going to predict the normal and abnormal values in the data set. Then click classify. So here we classify the data based on the rules. So here we are predicting the abnormal values based on the rule 2. So these values are predicted under the rule basis. So then predict, here we display the values, then matching with this is the actual ID in the data set, actual value in the training data set. This is our predicted by SVM classifier. So in the data set we have a total count value is total number of records in the data set is 648. In that we have a correctly classified instances is a 528. We achieved the accuracy level as a 76.74%, and incorrectly classified instances is a 160. That accuracy level is 23.25%. And this is a process of SVM classifier. Next we discuss about the classifier called decision tree. So we will select the decision tree button, then go to your dataset location. Just browse your dataset location from your system. So in that we have dataset named called so in that we have a dataset name called cancer data CSV. So in that we have a data set. So just convert the data set into the ARF format. So in that we have a relation name, then attributes in the data set, then we have a data in the data set. Then extract the data, then load the data into the database and classify the data set into the database. Then extract the attributes, then standard deviation of the data set, then click decision tree. We calculate the information gain, then bound for information gain. And then for every attribute, here we are calculating the information gain based on the formula. Then here we are calculating the Gini value for every classes, and then for data set, then calculate the Gini index of every value in the data set. Then here we are calculating the probability statistics of attributes, then calculate the Gini index of that values. Here we are calculating the Gini index value, and then gain ratio value. Here we are displaying the attribute information gain of attributes, then split information gain of attributes, and gain ratio. Then here we are calculating the Gini ratio. Here we are calculating the decision maker of every attributes in the data set. Then here we are split and pruning the examples, split and prune the values in the data set. Here we calculate the tree for that values. This is a decision tree for that value. Then here we are calculating the performance, evaluating the performance based on the time consumption, and then space consumption based on the space parameter. Here we are calculating the evaluating the graph. So this is a complete demo for our process. Thank you for watching.